Today we're going to try to solve LeetCode problem 220, contains duplicate 3. And before we jump into this problem, we can try to solve the problem 1 and 2 first. So 1 and 2 are easy problems. Let's take a look at the first contain duplicate problem. So given an array of integers, find if the array contains any duplicates. Your function should return true if any value appears at least twice in the array, and it should return false if every element is distinct. So here's the example. So 1, 2, 3, 1, it returns true because we have duplicated 1 here. In the second example, 1, 2, 3, 4 returns false because we don't have any duplicate. And in the example number 3, it returns true because we have duplicated 1, duplicated 3, duplicated 4. So we need to write an algorithm to check whether the input array has duplicates. Well, the first implementation gonna be a brute force implementation. We check from every individual element in the array, try to look for its duplicates. That's gonna be a big O n square solution. We can try to implement it. It's not a good solution, optimal solution, but we can at least give a try. Right? So if we find a duplicate here, we just return true, otherwise we return false. Okay. So this, as I said before, this is not an optimal solution. It has a time complexity n square. Let's see what's the runtime and memory usage of this implementation. So as you can see, it's pretty slow. So the second solution, I think we can implement is we can sort the array first, and then we can compare every two adjacent elements, right? So sort array, we can call the API array.sort, which takes a log n time complexity, and then we do a linear search. So at the end, the time complexity gonna be dominated by the sort, which is n log n. We can try to code that. The corner case check is the same as this solution, but we need to do a sort first. And then what we do is we start from index number 1 and to the end. If we find duplicates, right, let's compare. So this one should be slightly faster than the previous one. Okay, actually it has been improved hugely. And what else we can do? So when we see the problem description says we want to check the duplicates, can we use some data structure to do that? I think what we can do, we can use our hash set. And then we basically check whether the hash set contains the current number. If yes, we return true. If not, we just add the current value to the hash set, right? Oh. So this one should only take O n time complexity, but the drawbacks of this implementation is it gonna take O n time space complexity as well, because we have to maintain this hash set, right? So the first solution has time complexity n squared. The second implementation takes time complexity n log n, and the third implementation has time complexity O n. So, but you know, the third one has worse space complexity. Okay, so let's check the second contains duplicate question. So given an array of integer and integer k, find out whether there are two distinct indices I and j in the array such that the number I equals the number j, and the absolute difference between I and j is at the most k. So we first need to make sure the two numbers are duplicated, and then we need to check the indexes of these two numbers should have an absolute difference that is equal or less than k. Let's take a look at these examples. In the first example, we are given array 1, 2, 3, 1. So the two ones are duplicated, and the index is 0, 3. So yeah, so the absolute difference should be less than or equal than 3, so it returns true. Okay, the second one, yes, returns true, because the last two ones satisfy the requirement, right? And in the third example, the first duplicated number is 1, but the difference between the indexes is 0. This is 1, 2, 3, 3. So 3 is larger than 2. Okay, the second duplicated number is 2, and the difference of the index is 3, which doesn't satisfy the requirement. So let's check 3. Yeah, same thing. So in the example number 3, it returns false. Now I'm thinking we can probably use a dictionary and to maintain each distinct element, and also we store the index. Every time when we find duplicates, we check the indexes, and also when we traverse the array, we can update the index. Let's try to code it. If numbers is null, or numbers length is less or equal 1, we know there's no duplicate, right? We just simply return false. Okay, now we maintain a dictionary or a hash table. Okay, so the key gonna be the distinct number, and value will be the last index. Okay, and we gonna iterate the array. Okay, so if the dictionary already have the number here, what we do is we check the absolute difference between these two numbers, right? So if I minus this index is less or equal to k, we return true. If we contain this number, but the index difference is not satisfied, we update the index, right? Otherwise, we just add the number and its index to the dictionary. Right, and return false if we can't find these duplicate numbers. Let's compile the code. Okay. Okay. So time complexity gonna be O(n) because we just do a linear search, right? the space complexity also gonna be on. The dictionary has at most n numbers, where n is the number of elements in the input array. Okay, now eventually let's go to this problem, the content duplicate 3. So it's quite similar to the second contains duplicate problem. Give an array of integers, find out whether there are two distinct indexes I and j, and the absolute difference between numbers I and numbers j is at most t, and the absolute difference between I and j is at most k. Okay, so the difference is now we allow numbers I and numbers j be different as long as they have an absolute difference which is less or equal to t. We return true. Okay, so let's take a look at the examples here. Let me first write down what we need. So we need to find two numbers. The first is the absolute difference between numbers I and the numbers j is less or equal to t, right? And the second one is the absolute difference between these two index gonna be at the most k. Okay. So in the first example, so when t is 0, basically we need to find the same number, duplicated number. So 1 is here. The difference of the index here is 3, so the requirement conditions are satisfied, so we return true. For the second one, so the difference between these two numbers is at most 2, and yeah, the last one, 2 ones here, the index difference is 1, and the absolute difference between the values elements here is 0, so it's satisfied, so we return true. So here the difference of the two numbers should be equal or less than 3. So this is 4, this is 4. No, we can't find such a number pair, so we return false. So what does this mean? So basically we need to do something like this. Let's say we have an array, okay, and say we are here at index I. So we need to check, so in this range, so this one gonna be I minus k, and this one gonna be I plus k, right? So in this range, we need to find a number pair that the absolute difference between them is at most t. So it's like a sliding window problem. We maintain a sliding window of size 2k plus 1, right? And we need to find the number pair. What we can try is to use a provided data structure called sorted set, because sorted set provide an API which we can get view by providing its lower boundary and the upper boundary, right? If we find a value pair that satisfy the requirement, we return true. Otherwise, we move the sliding window rightward by 1. Okay. Let's try to code it. Okay, so always we check the corner case. So here we need to make sure the absolute difference is greater than 0. If not, we should return false. Okay, then as I said before, we can use a sorted set. So what we do here is we iterate the array and use the API to find the value pair within the sliding window. Let's do that. So if get view between so the first element gonna be the low boundary. The low boundary gonna be numbers I minus t. The up boundary will be numbers I plus t, right? If we find such a number, what we do, we just return true, indicating we find that number, right? If not, what we do, we need to move the sliding window. We need to move the sliding window upright by 1, right? So this is going to be our I plus 1, and accordingly, we move the entire sliding window rightward by 1. So we first check whether we need to remove the first element here from our current sliding window, because we want to make sure the sliding window size is fixed. So what we can do here, yeah, we basically just need to check whether this index I minus k is equal or greater than 0. If yes, we remove it from the sliding window and then we add a new element into the sliding window. Yeah. Okay, let's add it first. Numbers I. Now we need to check whether we need to remove our first element. If yes, we remove it. If we can't find such a value pair, we return false. Okay. Let's compile. Oh, worked. And let me try some other test cases. 1, 2. 2, 3. Okay. True false. Expected true false. Okay. We failed here. What's going on? So these are two numbers are given in the array. Okay. And the difference between these two should be less than 100. And the difference of the indexes should be equal or less than 1. Okay. But why? Oh, it says must be less than or equal than the up value. Lower, so the lower one. Oh, maybe it's overflow, right? Let me see. Yeah, I think it's overflowed. Yeah, it's overflowed. Because when we add up these two numbers, as you can see, it will larger than the maximum value of integer, right? And the maximum value of integer is like 20 billion something. Yeah, so this is the maximum number of integer. Okay, so what we can do, instead of using the integer, we update the integer with long, and we don't need to print out the numbers. And before we do, we convert the integer to long here. So this will do a implicitly conversion here, convert integer to long, so it should be fine. Okay. Okay. Let's submit it. Okay. Yeah, so yeah, I made a mistake, and whenever we do the add or subtrate operation onto integer number, we need to consider about the overflow. And do we have any other possible solution to solve this problem? Because possibly I don't know this API, right? I think what we can do, since we used a sliding window here, so normally we can use a dictionary to maintain the element within a sliding window. So can we have the same idea, use the dictionary? So if we want to use a dictionary here, what gonna be the key and what can be the value? Right? What is the key and what is the value? So I think what we can do is because I think we can map all these numbers to different buckets, I think. What I mean is, like, for example, we have 1, 2, 3, 4, 5 here. And let's say we have t, which is, let's say, 2. Okay, if we can have a bucket, we put 1, 2, 3 here. Right, the first 3 numbers we put in the first bucket, and then the second bucket we have 4 and 5. Even we have 6, okay? Right, so in this way, what we can guarantee is that within the bucket, the absolute difference of any given 2 numbers will be at the most t, right? So, but the problem here is we may have 2 elements, let's say 3 and 4. They are not mapped to the same bucket, but they also satisfy the requirement that the absolute difference between these 2 is at the most t, which is 2 in this case. So now what I'm thinking is, if we can have a hash table dictionary, right? The key gonna be our bucket number. Okay, bucket number. And value gonna be our number. So in general, there are only two cases, right? The first case is when we try to add a value into our bucket, and our bucket already have a value, which basically means we find the value pair. Or we have the second case that we don't find any number in our bucket, but we find a value in our neighboring bucket, right? So we need to check these two, whether these two numbers meet our requirement. So will that work? How can we guarantee the difference of the indexes is at most k? Oh yeah, we just need to make sure this dictionary only has at most k numbers of value key pair, right? Key value pairs. And we can use the same strategy as long as the dictionary has more than k key value pairs, we remove the first one. But what if we have negative numbers? Will we have negative numbers? Yeah, we will have negative numbers. So what worries me is when we have negative numbers, let's say we have 1, 2, 3, and 4, 5, 6. So 1, 2, 3, we can use divide operation, right? We can do number divided by t plus 1. We map 1, 2, 3 to our bucket 0, right? 1 divided by 3, and 2 divided by 3, and 3 divided by 3. They all goes to the 0 bucket. But the problem is if we have a negative value, say -1, if we use this calculation, -1 divided by 3, it will goes to 0, bucket 0 as well. So ideally we need this number, -1, -1, goes to bucket -1. What we can do is we plus this number by 1. So it becomes 0, and we use the same divide operation, map it to 0, and then we subtract by 1, so it will goes to 1, -1. Will that work? it becomes complicated, right? Yeah, but it's possible we don't know this API. In that case, we need to write something else, write a different solution. Let's give a try. Okay, let's just delete it. We need to maintain a dictionary. Now we need to be careful because we know it's gonna have overflow. We need to take care of that. Okay. And we iterate the array. So the first thing is we need to get the bucket ID. What we do here is we need to pass the character number and then t+1, right? And we can implement that function later. But it can be a long number, right? Okay, get bucket ID. Let's call it bucket size. Okay, we can implement it later. Okay, so as long as we have the bucket ID, and if the dictionary of that bucket ID already have a value, right? We return true. Otherwise, we check the neighboring buckets. Right, so if the dictionary at the previous bucket is not null, I should do this. Contains key bucket ID -1 contains, so we have the number. Okay, and also our current value minus that number is at the most t, we return 2, right? Actually, we can combine these together. Combine these cases together. Let's check our right neighborhood bucket. So it can be +1 and switch the order. Do I need to switch the order? No, what I actually need to do is I should use this function to check the absolute difference. Okay, so in these three cases, we're gonna return true, right? Otherwise, what we do similarly, we need to move our slider window rightward, and we also need to check whether we need to remove the first number from our sliding window. Okay. So dictionary add, we add the number first, and then number size. And we need to check whether minus k is equal or greater than 0. If yes, we need to remove that number from the dictionary. So since we are storing the bucket ID in the dictionary, right? I think what we need to do is we need to find the index of that first element. Numbers I minus k and t plus 1. And we remove it. Okay. Now we need to implement this get bucket ID. So if number is equal or greater than 0, what we simply do is just return this one. We'll call it bucket size. I think it's too complicated. My function make it clear. Okay, I let my get bucket ID to handle the bucket size. Okay. And then we divide by t plus 1, and we need to minus 1 to map the first negative to bucket negative 1. Okay. So this is going to be our implementation. Let's compile the code. Line 17. Oh, okay, so this basically checks whether we already have a number in this bucket. And 25. Sorry. Okay. Let's try one more test case. Yes, let's submit it. Okay, so it works. So the time complexity of this one, we basically just do a linear search here, right? And we check the neighboring bucket, and we maintain the sliding window. So this is gonna be a O(n) time complexity solution, which might be a little bit better than the previous one. So the previous one, since we are using this API, I really don't know how the API is implemented, but my idea is, so sorted state should be implemented on top of the tree data structure, right? So I guess this probably just OH time complexity API, which H is the height of the tree, which is gonna be log n. Right? So this is gonna be the entire solution, whole solution here will be n log n because we have a loop which add O(n) time complexity to the solution. So overall, I think the third, how many solutions I provided? Can't remember. Oh, okay, I just implement 2 solutions. I think overall the second solution is better because it has less time complexity. And but the second solution is more tricky, right? I think it's more tricky because we need to check 2 cases. We need to check the current bucket. We need to check the 2 neighboring buckets. And we also need to maintain the current bucket. And also, this get bucket ID is not straightforward if we need to map our negative value to -1 bucket, right? As that bucket is the baseline. Yeah, but I mean, this is a very good question. Comparing to the first one and second one, the contains duplicate 3 is more complicated. I think that's why it's marked as media. Okay, and that's it.